Hi everyone. Hi second year students of Federal Board. It's Math with AUB. Exercise 3.4. We are asked to integrate by using integration by parts. Integration by parts. Integration by parts. Two ideas have been floated to integrate by parts. First one is isolate. Some people used to prefer LIATE. To me, these two are interchangeable, but they both are not present. Inverse and logarithmic, they are not present in a single data. While trigonometric and exponential, they are interchangeable. And I can prove in this frame. ILATE means I stands for inverse functions that you are familiar. Inverse trigonometric function, inverse hyperbolic function, inverse function. Second, L stands for logarithmic. Logarithmic. A algebraic having x square, whatever the case is. Algebraic. T T trigonometric. T trigonometric. E exponential. E exponential. Exponential. This idea has mostly been floated to integrate by parts, shedding some light on this. I inverse, L logarithmic, A algebraic, T trigonometric, and E exponential. They become the master of mathematics and they are mathematicians. To me, no doubt it has some significance, but mark my words, take the first one whose integration is not known. For first and all, the first thing and the last thing. Take the first one whose integration is not known. Take the first one whose integration is not known. Take the first one whose integration is not known. Take the first one whose integration is not known, and it is wonderful for you. Check in. If integration of both function is known, if integration of both function is known, then try to take the first one whose derivative decreases or diminishes. Whose derivative decreases. If the integration of both function is known, number one, take the first one whose integration is not known. Take the first one whose integration is not known. Second, if integration of both function is known, then try to take the first one solidly whose derivative diminishes, decreases, whose derivative decreases. Let's see and find out. And I have given you the idea inverse logarithmic. There is a dispute how to choose the first one. How to choose the first one? It is selection of the first function. Selection of the first function. Inverse, logarithmic, algebraic, trigonometric, and exponential. Exponential. ILAT. Some literature used to write LIAT. To me, they are interchangeable. T and E. L and I, they are not present in a single question. If so, please share with me. Okay, let's see. Question number one is ln x dx. Simply ask yourself, is it differentiation of something? Is it derivative of some function? Obviously, the answer is negative. The answer is no. It is not the function of this one. For by parts, we take two functions. We take two functions, ln x. One we can manipulate and introduce according to Euler rule. If so, there is no inverse function. There is second one is logarithmic. So this one is our first function. This one is our second function according to this. But what I have told you, take the first one whose integration is not known. If its integration would have been known, I have written directly. So integration of ln x is not known. Integration of ln x is not known. So it is our first function. It is our second function. According to Euler rule, logarithmic should be the first in that case. What is by parts? This is the formula for by parts. Inverse, first same, right? First function same, integration of second minus whole integral, derivative of first function. D stands for derivative, integration of second, integration of second. First function is same, first function same, integration of second, integration of one, first same. That's our u, that's our v. First same, integration of second. minus whole integral. Differentiation of first, derivative of ln x with respect to x into integration of second. Second one is this one. Always hunt the first one whose integration is not known. Whose integration is not known. First preference, first preference. And this is also parallel with Eilert rule. There is no inverse function, there is logarithmic function, so I have taken the first one. To mine rule so simple, that is take the first one whose integration is not known, that is also ln. In both situations, what prevails? Take the first one whose integration is not known. Number one priority. Ln x first, integration of second, minus whole integral, differentiation of first, integration of second. Do so. Do so in that case. Ln x same. Integration of 1 is x minus whole integral. Differentiation of ln x is 1 over x. Integration of 1 is x times dx because the integral symbol present. Yeah, when neutralized, cancelled out. Ln x times x, they cannot be square. They are two separate functions. Write in that fashion, x ln x minus 1 dx. Still there is integration sign. Integration sign, integrate. We have x ln x minus x plus c. So that's our answer. Or take common from the first two terms, x common. We have ln x minus 1 plus c. That's our answer. That's our answer. Take the first one whose integration is not known or utilize Eilert rule as you feel comfortable. Take the first one, inverse is not present, logarithm is present, and its integration is not known. So in both cases, it is our first one. I have written first same, integration of second. I have written the same formula for you in words. Try to follow this. First same, integration of second, minus differentiation of first, integration of second, and here is the independent variable, whatever it is, dx or dy. Dx or dy. Ln x, integration of second, that is x. Differentiation of first, ln x derivative is 1 over x. This is x. X neutralized. Still there is integration 1 dx. Its integration is x. So its integration is x ln x minus x. It's really very simple. It's really very simple. Have a look at this. First same times integration of second minus whole integral. Differentiation of first, that's ln x. Integration of second times, here it is dx. First same, integration of 1 is x minus differentiation of ln x is 1 over x. Integration of 1 is x. Here is dx. Cancelled out. We have x ln x minus 1 times dx. The still integral symbol is present. Integrate x ln x. Integration of 1 is x plus c. That's our answer. That's our answer. Moving towards same question. Having ln, a logarithmic function, it should be the first one. It should be the first one. It should be the first one according to Eilert rule, or according to the strategy, take the first one whose integration is not known. Take the first one whose integration is not known. Here it is ln x square times introduce 1 dx. It's our first function, it's our second, it's our first function. Take the first one whose integration is not known. Ask yourself, ln x square is differentiation of something? The answer is negative. Write first same, ln x square, integration of second, minus whole integral. Differentiation of first, that is ln x square, integration of second, 1 times dx. X is our variable dx. First same, that is ln x square, integration of 1 is x minus whole integral. Differentiation of ln x square, drag the power down, subtract 1 from the power, make the power coefficient, drag the power down, subtract 1 from the power. What is the derivative of base? Differentiation of ln x is 1 over x times integration of 1 is x, here is dx. Cancelled out. It can be arranged as x ln x whole square minus 2 times ln x times 1 dx. Look, again it is our first question. Again it is our first question. ln x again by parts. Again by parts. Again by parts on this. Again it is our first, it is our second. Write these two same. X ln x whole square minus 2. First same integration of second minus whole integral differentiation of first times integration of second. Here, because of this integral dx, we have same x, sorry, x is outside this, x ln x square, x ln x square minus 2 times ln x integration of 1 is x minus overall integral differentiation of ln x is 1 over x, integration of 1 is x times dx. They are cancelled out. One remains here. Again integrate one time. Let me check the frame. Okay, I can manage here. It's all something x times ln x square minus there's 2 x ln x minus 1 dx. Again integration of 1 with respect to x, I have x ln x whole square minus 2 times x ln x, integration of 1 is x plus. Look, it is same as the integration of ln x. It is same as the integration of ln x. We have did so. There is a square. We have to apply integration by power 2 times. If there is cube, 3 times. This power is 4 times, and so on. So our final answer is x ln x whole square minus multiply negative 2x ln x minus plus 2x plus c is our answer in that case. Again, same strategy. Our first function must be the function whose integration is not known. Obviously, it is ln x whole square. Write it same. Integration of second 1, that's dx. Differentiation of first function, integration of second. Just simplify ln x square. Integration of 1 is x. Differentiation of ln x square is drag the power down, make the power coefficient, substitute 1 from the power. What is the base? ln x differentiation of ln x is 1 over x. Integration of 1 is x, something cancel out. What remains here? ln x. Again, bingo. By parts, it's our first, it's our second. Because integration of ln is not known to us. Again, by parts. To my negative to outside, right first. ln x integration of 1, I have written that's x. Minus whole integral difference. Derivative of first ln x, that is 1 over x. Integration of second, that's x. Cancelled out. Here remains 1 dx. 1 dx. Integration of 1 is x. That I have managed for you here. It's our answer in that case. Moving towards same question. Look at this. There is ln in the angle as well. ln in the angle. Again, same. This is whole the composite function. It's a single function sign having argument ln x, having argument ln x. It is to be taken first. The second function obviously is 1. 1 always assists us. 1 is going to assist again. Sine. Sorry. Question number 3. Sine. Argument is ln x times 1 into dx. Okay. Let me write in that fashion. Not to confuse multiplication symbol with x. This is our first, this is our second. Write first same. Sine ln x. Integration of second, that is 1. That's our u, that's our v. Whole integral. Differentiation of sine ln x times integration of second 1 dx. Overall variable is x. U v, that's our u. Integration of second. Differentiation of first, integration of second. In both cases, integration of second. Here first term, differentiation of first. So I have sine angle is ln x, integration of 1 is x minus whole integral. Differentiation of sine, differentiation of sine, differentiation of sine is cos, angle same, argument same. Differentiation of sine is cos, differentiation of sine is cos, argument same. Then the differentiation of argument, that is 1 over x. That is 1 over x. Again, differentiation of sine is cos, argument angle same. Then differentiation of argument angle, that's 1 over x. Times integration of 1 is x dx. It's cancelled out. I can arrange this as x sine ln x minus I have cos ln x times dx. Again by parts here, because ln is still present. Whether or not it is an argument, it's okay. Still at the end, at the commencement, we have started sine ln x. We apply by part. Instead of sine, now we have cos. Again, we have to apply by parts. Again, we have to apply by parts. X sine ln x minus by parts again. First same integration of second, that's obviously 1 dx minus whole integral. Differentiation of first, differentiation of cos ln x, integration of second, 1 dx overall integral having dx. Same x sine having argument ln x, cos same, cos integrate angle argument ln x, integration of 1 is x, minus whole integral. Differentiation of cos is negative sine argument angle same. Differentiation of cos is minus sine. Argument same. Then the differentiation of argument angle, that is 1 over x. Integration of 1 is also x dx. Again cancelled out. X sine ln x. It can be written as multiplying minus x cos ln x. Look at this. Minus plus, and there's a minus. Again that is negative. Sine times ln x dx. Look at this. We have again reached at the point where we have started. The data repeats. After twice integration. So how we can handle this? How we can integrate this? Infinite loop or chain. This is our original integral I. From on the left hand side, I can write I overall. I have written I. This is our again I. That repeats. This is I. Let me write x sine ln x minus x cos ln x. This data repeats. I can write instead of this again integral I. Shift I here. I plus I, it will become 2I. I plus I, it will become 2I. Here, whether to take x common or not, let me take common. X common. Sine ln x minus cos ln x. No more cos will introduce c. I plus I, it will become 2I. I plus I, it will become 2I. Same, x times sine ln x minus cos ln x plus c. We are interested in I. Integration of original integral, only integral sine dx. Shift 2 here. It will become x over 2 times sine ln x minus cos ln x plus c. It's our answer. I, instead of I can write the data, that is integration of sine ln x dx is this one. In such cases, whether we have given cos ln x, when the data repeats, introduce I, starting I, this is also I, take I to I, merge them, whether add or subtract them according to their symbols, then solve for I. Let me check the frame. Is it good? Is it? Is it good? Okay. Moving towards next question. Moving towards next question. I have. Oh God. Now our life is simpler enough after doing this question. X cube ln x dx. Look at this. Let me reconcile this with islet as well as what I have propagated to you on the outset. Take the first one whose integration is not known. Integration of this we can easily integrate x4 divided by 4. Integration of ln is not known. Integration of ln is not known. If you take a look at this one, inverse after inverse, there is the logarithm. So it should be the first one. It should be the first function and x cube the letter. Ln x times x cube dx. dx. First same integration of second u v integration of v dx. Overall negative sign. Differentiation of first function into integration of second because of this integral overall dx, because x is our variable. ln x integration of x cube is x4 divided by 4. Differentiation of ln x is 1 over x. Differentiation of x cube is x4 over 4 dx. A tiny calculation here remains x cube. There's x, there's x. There remains x cube. I can write this in that fashion: 1 over 4 x4 times ln x minus 1 over 4 outside integral symbol x cube dx. In a simple algebraic function x cube, add 1 into the power. Writing the rest same: 1 over 4 x4 ln x minus 1 over 4 integration of x cube is x4 divided by 4. It will become 4 times 4 16. So we have something like that: 1 over 4 times x raised 4 times ln x minus 1 over 16 times x4 plus c, or one can take x4 common from this. X4 common from this. Either isolate or take a single sentence. Take the first function u whose integration is not known. Whose integration is not known. Whose integration is not known. If integration of both function is known, then take the first one whose derivative decreases or diminishes. Question number 5. Question number 5, that is y times sine 2y dy. Look at this. What's our strategy? Take the first one whose integration is not known. In that case, integration of both function is known. Integration of y is y square over 2. Integration of sine is negative cos. Negative cos. So integration of both function is known. Then we have to take the first one whose derivative diminishes or decreases. If we take sine, sine cos minus sine cos, sine cos, sine cos, alternating and so on. Take y the first one. Y. Differentiation of y is 1. Then y is no more. Then y is no more. So it is our first function. It is our first function. It is our second. In case if integration of both is known, take the first one whose derivative diminishes or decreases. That's by study or philosophy. Let's reconcile this with that one. Inverse law, there is algebraic. Then we have to prefer algebraic. Whether according to this or applying your common sense acumen or conventional rule, this one, whatever you want, go ahead. Take the first one whose integration is not known. Number 1. Number 2, take the first one whose derivative decreases or diminishes. If the integration of both function is known, then take the first one whose derivative decreases or diminishes. So it is our u, it's our v. Making life simple, put in formula, first same, that's u, integration of second, sine 2y dy, negative, overall integral, differentiation of y with respect to y, because our independent variable is y here, times integration of second, that is sine 2y dy, another dy owing to this integral dy. Y same, integration of sine is negative cos 2y Angle is a multiple of 2 dividing with the same. Dividing with the same. For the differentiation of angle 2y, we have to divide with the argument's derivative. With the argument derivative. Whatever the multiple of angle, we have to divide in case of integration. In case of differentiation, we have to multiply. Minus whole integral. Differentiation of y with respect to y, that is what? Integration of sine is same. Integration of sine is negative cos. Argument sin, what is? Argument is multiple of 2. So differentiation of 2y is 2 dividing by 2 times dy. We have this minus 1 over 2 can be written as minus 1 over 2 y cos 2y minus plus it will become 1 over 2 times integral is present cos 2y dy. Here is a single function. Integration of cos is only sine. Don't forget to divide by 2 owing to the multiple of argument angle. Negative 1 over 2y cos 2y plus 1 over 2. Integration of cos is sine 2y dividing by 2. Owing to the differentiation of angle 2y, differentiation of 2y is 2 dividing with 2. So it will become 2 times 2, 4 in denominator. 1 over 2y cos 2y plus 1 over 4 sine 2y plus c. It's our answer in that case. It's our answer in that case. It's our answer in that case. Mark my strategy, mark my philosophy. If integration of both function is known, then take the first one whose derivative decreases the definition, or it is parallel to this. There is no inverse, no logarithmic. Then we have to prefer algebraic. That's why is our algebraic. Final question, the sixth question of today's frame. Here, integration of both function is known. That is e raised x times cos x. E raised x times cos x dx. So on the outset, I have claimed that these two are interchangeable. We can write et. Trigonometric first, then exponential, or exponential function, then trigonometric. I am about to prove this. Here you can see. Differentiation of both function is known. So prefer trigonometric function according to this rule. Cos x times e raised x dx. Okay, applying my parts. You say integration of second e raised x dx minus whole integral. Differentiation of first cos x integration of second dx. Cos x same. Luckily integration of ex is dx. Differentiation of cos is negative sin x. Integration of e raised x is e raised x times dx. Owing this integral, it will become negative positive cos x e raised x minus plus again sin times x dx dx. Look at this. Trigonometric exponential, we have given the preference to trigonometric function in that case. It's RU, it's RV. Again by parts. Again by parts. Same. It will become e raised x times cos x plus first same sin x integration of second e raised x dx minus overall integral differentiation of first differentiation of sine differentiation of sine and integration of ex dx. Owing to this integral, there is dx. One more. I have e raised x times cos x plus sin x. Integration of e power x is e power x minus whole integral. Differentiation of sine is cos times integration of dx is again dx. Look at this. We have reached at the point where we have started. So it's our I. Let me write I on this side. That's left. I is equal or integral is equal to I equal. Okay. I equal e raised x cos x plus sin x e raised x. This is our again integral cos x times e raised x or ex times cos raised x. That's our integral I. Shift merge I to I. I plus I. From here, one can take e raised x common. What we are left with? Cos x plus sin x plus c. I plus I, it will become 2i. I plus I, it will become 2i. E raised x cos x plus sin x dividing by 2. I is equal to, it is our e raised x divided by 2 cos x plus sin x plus c. Our I is no doubt e raised x cos x dx. That's our answer. That's our answer. In that, according to the Eilert rule, I have taken trigonometric first. I haven't given preference to exponential. If we do so, there's not sky is going to fall. The result is still same. The result is still same. They have the flexibility to be interchanged. Let's see and how. Let's see and how. Let me prove this my claim here. Okay, now we are going to prefer exponential first. This is our u, this is our v. Let's see and find out. E is x same integration of cos dx minus whole integral. Differentiation of first, that is e raised x. Integration of second, cos x dx. Another dx owing to this integral dx. Or owing to this integral dx one more. I is equal to e raised x. Integration of cos is only sine. Differentiation of ex is only ex. Differentiation of cos is minus sine. Sorry, integration of cos is only sine. There's integration. Integration of cos is only sine dx. Here, again, same situation. Instead of cos, we have sine. Again by parts. Again by parts. We have given preference in this case exponential. This is our u, this is our v. Again, one more time by parts. I e raised x times sin x minus first same integration of second, that is sin x dx, minus overall integration. Differentiation of first, differentiation of exponential function times integration of second, that is sin x dx, another dx owing to this integral. Okay, we have I is equal to e raised x sin x. Integration of sine is minus cos. Integration of sine is minus cos, minus whole integral. Differentiation of e raised x is e raised x. Differentiation of sine is negative cos x dx. Look at this. It will become minus minus plus. If you multiply this minus, it will become, okay, letter matter first. I reconcile these two brackets, then I multiply minus. Okay, stepwise. I is equal to e raised x sin x times it will become negative e raised x cos x. Here, what remains here? Integration symbol. Minus minus, it will become plus e raised x cos x dx. Look at this. We have reached, we have converged where we started. We have to introduce instead of this I, first multiply this minus. It will become negative negative, positive negative times positive, it will become negative. So we have something like that. E raised x sin x plus e raised x cos x minus plus minus, that is mine, e raised x cos x dx. The data has been repeated. The data has been repeated. It's our I. It's our I. Shift here. So I have I plus I is equal, taking e power x common. What I have? Sin x plus cos x plus c. I plus I. It will become 2i e raised x cos x plus, okay, sin x plus cos x or cos x plus sin x. It's interchangeable, but follow me the routine. That's sin x plus cos x plus c cos x in a proper fashion. Shift to here. So I is equal to, so I is equal to e raised x divided by 2 Sin x plus cos x plus. Look, answer is same. Answer is same. So I have made my proof. I have given you ample proof. Trigonometric and exponential function, they are interchangeable. They are interchangeable. At your second year level, no data is present having inverse and logarithmic at a time. No data is present having inverse or logarithmic at a time. Otherwise, I would have proved their interchangeability doesn't affect the result. Their interchangeability doesn't affect the result. So see you in the next frame from 7 to 12. It's my tiny effort to you guys to show you the right path, to show you the concept rather than mugging up or cramming or follow the routine. It's all by itself. Next.